Okay, this is 2013 FRQ number 5 from Mr. Ferrar's class. Before I begin, if you have any questions after the video, I've attached some useful links underneath this video. And without further ado, let us begin. So, first step, since this problem doesn't include, or it doesn't tell you which line is g of x and f of x, you have to label them yourself. So actually in this case, the top one would be g of x. And you know this because f of x is a parabola. And in the graph that they give you, this bottom line has a distinct parabola shape, whereas the g of x does not. So we'll label the bottom one as f of x and the top one as g of x. So part A asks you for the area of R. So to do that, you're going to take the integral of g of x minus f of x, or the top minus bottom. You have to set the interval of this integral from 0 to 2, because that's where the two intersection points of g of x and f of x are. So it would be integral 0 to 2 top minus bottom d of x. And here's what that looks like plugged in. So the next step of part A, since it's a non-calculator version, you would have to manually do the integral. So you can split up into two parts, the integral of g of x minus the integral of f of x. So here's what that looks like down here, and here's the work for that. And after you have the integral, you set it all, remember your interval at the beginning from 0 to 2. You're going to just plug that right in and simplify and simplify, and your entire answer should be 6 pi minus 4 over 3. And this entire thing works because if you think about it, you're finding, to just find the area underneath a curve, it would be integral of g of x. But then there's an imaginary minus 0 over here that makes it so that this is finding the area bound by the x-axis. But in our part A, we don't want to find the area bound by the x-axis. We want to find the area bound by g of x and f of x, rather than g of x on the x-axis. So you're going to replace the 0 with a f of x. And that's why this entire thing works for part A. Okay, so part B of this problem asks you to find the volume of R rotated around the line y equals 4. So since this is a rotational problem, you'll be dealing with the integral, or first of all, integrals for the area between the two curves once again. And then you're going to have the inside squared and add a pi at the beginning, because that would represent the area of a circle, as I have down here. Pi integral a to b of a function squared looks really similar to pi r squared. And since that is because you are just finding a bunch of different circles that are rotating around the axis, or the line y is 4, and then adding them all up to get an entire volume. So the first step is to have a pi and then integral on your interval from 0 to 2 once again. And this time, because you're not rotating around the x or y axis, you have to have your line over here. And why I do this is because you're going to do, once again, top minus bottom. So now your new top is going to be y is equal to 4, and your new bottom is going to be f of x. because that is the greatest area. So you'll have 4 minus f of x squared, and that represents down here this entire area underneath the line y is equal to 4 in this case. So, but that's not what we're looking for. We want just r, which is just this area over here, not this entire area. So in order to get just this area r, you need to subtract all this extraneous area that's bound by 4 and g of x. So between y equals 4 and g of x, we want to get rid of. So we're going to subtract that area and then take the integral of that. And since this problem says just find the equation, do not evaluate, you can just copy the same thing and then just plug in f of x and g of x. And that is your answer. Okay, so the final part of this equation, or the final part of this FRQ is part C. Part C asks you tells you that R is the base of a solid and that each cross-section perpendicular to the x-axis is the base of a square. Find the equation for the volume of the shape. So what the shape is going to look like is basically you have your R area, and then the area or the distance between f of g and f of x is going to be a side of a square. So you're going to have a bunch of squares that look kind of like this all throughout the interval of r. So what that entails is, first of all, you're searching for the volume. So you're going to have a bunch of these squares that are going to have an area that need to be added up on the interval of r. So first of all, what that's going to look like is, well, you're going to have your integral from 0 to 2, and then you're going to have the area of a square, which would be the side of the square, or s squared. So now you have to find what that side is equal to. And in this case, the side is going to be high minus low. So it's going to be g minus f is going to be one side of the square. So now you have your integral from 0 to 2 s squared. You know what s is. All you have to do is plug in g minus f for s. And since this part only asks you for the equation, it does not ask you to solve for the volume, you can just leave it in this form.